Hey, this is Brandon. You're watching the series where I solve the leak code daily and then get it on one line. Let's see what we got today. So you could do multiple fancy things here, but I think like it's a question of like time complexity. I'll say O of n is the length of items, m is the length of queries. Am I going to be able to get this in O of n times m or O of m or something like that? What's O of n plus m? What's the best I can do? If I sorted the items by their price, then I could take a prefix maximum, something like that. That's not a bad way to go. Although I'm thinking I could just throw them in a sorted list would be a really easy way to do that. But I kind of want it to be like I don't ever want I don't ever want an item that has a higher price than something and a lower beauty than something. So what I could do is like items.sort and then stack is this for PB price and beauty in items. Or I'll just say X in items because I kind of want the item. I'll say this is A. The names are going to get a little confusing. If A and A at -1 at 1 is, the beauty has to be higher. If it's lower or equal, then I don't really care, right? Is less than X at 1, A dot append X. Let's see what this comes up with. Okay, so it says you only really care about 1 and 2, 2 and 4, 3 and 5, 5 and 6. That seems right. So now I could just say like map something to queries, and I'm already going to call this Q. So we're going to map something to Q, and what we're going to map is just like, what am I doing? Am I mapping the index? If I'm mapping the index, that's like really annoying. You want to determine the maximum beauty? No, it's just the maximum beauty, thank God. So we want to get the index in this sorted array when we are given the maximum price. So we'll say bisect less than or equal to, so bisect right something -1. If no such item exists, then the answer to the query is 0. So we probably want like a default here that's like 0, 0. And I'll say -infinity 0. The price of that is -infinity, so now this will never go through. And I'll just check to make sure that this works. Bisect right, I'll just say lambda x, bisect right ax -1. It's going to give some sort of answer. Okay. Now we're given the index. Yeah, we're given the index. Now we want to map this to two things. It's going to be like A at that index at 1 to get the beauty of that. So map item getter 1, map A dot get item. Okay, cool. And to just get this all on one line immediately, I really just need to say like A colon equals something. I guess I'll do this in 2 lines. So I'll say like A colon equals that and map something to items, but I'll call it I, which is a little sketchy, but I don't actually call indexing anywhere, so that's fine. Interesting. Now I'm running into a really tricky problem. If I literally have this code and I say partial LT A -1, this is going to run an error. This is really interesting. But if I even just say, okay, instead of passing this function into the filter, say lambda x, this function of x, this runs properly, even though these two pieces of code are basically exactly the same. But they're not quite exactly the same because there's a really sinister bug going on here. What's going on when I have this is this function is being built at runtime once when the filter function is being built. So it'll say what's A at -1, 0, -infinity. And then it'll just go with that forever. But I don't want it to go with that forever. I want it to query A at -1 every time. So I wonder if this is the place where you could say partial call that. No, it still builds it like it builds it at runtime. All right, fuck it. I'm using lambdas. I don't care. So I got to build the array. A colon equals, I'll just say 0, 0. I don't care. And we got to build out the array. So map something I and map something to Q. And here I'll just say lambda j. It's just going to be array at j at bisect left a and j -1, bisect right -1, that could have been bad, at 1. That's going to be the maximum beauty that is less than or equal to the jth query's maximum price. Okay, and then I have to build out a. So I'm saying for everything in items, lambda x, it's going to be x at 0. No. X at 1, and this is going to be sorted I. X at 1 is less than a at -1 at 1, and a dot append x. Oh, it's because I'm looking for j, but I don't really want to look for that. I want to look for like the lowest element that has a higher price than j. So j -infinity, or I'll just say j and 0. I bet it's that this shouldn't be 0. Yeah, it's that this should be like infinity. Yeah, there it is. All right, well, I failed in my no lambdas escapade. I got rid of this first lambda. The second one I didn't even really attempt. It was just the at runtime evaluating partial functions that fucked me up. So if you do this, if you say like, okay, I want you to filter with this partial function, this is what really fucked it up, was this wouldn't work, but literally lambda x, this of x, would work. I guess you could just have this be a string and say specifically don't evaluate it until, like, you could do this or something. I don't even think that would work. I don't know how you would get around this, because this is a pretty hardcore, like, this exact function is what you want, and lambda x, this of x works. But if you just say call this directly, that doesn't work. At that point, I'm going to have to think about a way to get around that. But for now, I'm just going to be like, all right, fine. I'll use a lambda. There it is. Good runtime. Hit subscribe if you want to see more of my face.